just, I've already said this to the others, but a bit earlier, but just wanted to apologise in advance for a bit of a frame rate issue on the video. It's a Zoom issue, I believe, and I tried to get around it, but it looks perfectly smooth on our end. I hope it isn't too bad on yours. Okay, so around 2.4 billion people worldwide, around a third of the global population cook using open fires or inefficient stoves fueled by kerosene, coal or biomass, which could be wood or animal dung, all of which generates harmful household air pollution. Well, that pollution is believed to be responsible for around 3 million deaths a year, including over 235,000 deaths of children under the age of 5. It's feared over 500,000 deaths in Africa are caused by diseases linked to air pollution, much of which is caused by cooking using biomass in the home. And this biomass is mostly unsustainably tapped from forests the planet can ill afford to lose. The need for firewood and charcoal helps encourage Africa to clear an estimated 4 million hectares of forest every year, according to the UN. That's twice the world's average deforestation rate. Animal dung from farm livestock releases large amounts of methane, which has 80 times the warming power of carbon dioxide when in the atmosphere. Agriculture makes up as much as 10% of all greenhouse gases. That rises to between 15 and 25%, depending on which figures you use, when land use such as deforestation is taken into account. Now, farmers, unfortunately, in Africa pay much higher prices for chemical fertilizer than most European or North American farmers. As a result, Africa's agricultural crop yields lag behind the rest of the world, leaving it dependent on costly imports. And this contributes to the stark fact that of the 20 hunger hotspots identified by the UN's World Food Programme, no less than 16 are in Africa. The production and use of chemical fertilizers, when affordable, are a major contributor of CO2 and non-CO2 greenhouse gas emissions. These issues in rural Africa add up to a humanitarian, environmental and economic disaster, which affects 60 to 80% of the 1.2 billion population of the continent. This affects a huge number of people. But imagine if there was an affordable, simple piece of technology that would help reduce all of these issues, one that utilizes the near endless supply of readily available organic waste from agriculture and creates a clean energy source perfect for cooking or heating and suitable for generating electricity or powering vehicles also. The stuff of science fiction, perhaps? No, this exists. And the technology known as anaerobic digestion has been around a very long time. Records actually suggest the use of it date back nearly 3,000 years. So how does anaerobic digestion work? Digesters can be fed with most organic waste, and the good news is animal dung is absolutely perfect. The waste is broken down by microbes in the tank where crucially no oxygen is present. The process produces a usable gas known as biogas and also a low carbon fertilizer, both invaluable resources in rural Africa, of course. Now, in this animation, we see a relatively simple brick or concrete digester buried in the ground, the sort of system that a builder or even a farmer could construct relatively cheaply. On the left, we see the mixing tank where the dung is simply mixed with water. This slowly is fed into the digester's main chamber where there's no oxygen. As the microbes get to work eating the waste, this starts to release the biogas. The gas builds up and rises to the top where it collects. On the top, you can see a gas outlet pipe to a residential dwelling on or near the farm. And the gas can be used without any processing to cook on or provide heating. And the digestate, which is what is left after the biogas is removed, can be separated into a natural low-carbon fertilizer and a dry animal bedding. A fantastic real-world example of the circular economy in action. So having spotted the potential, there was widespread investment in China, for example, from the 1950s onwards. An uptake of anaerobic digestion systems really took off there. Today, there are believed to be around 5 million small household-sized systems in operation in rural Africa. In stark contrast, however, uptake across Africa appears to be very low. Figures for most African countries are hard to confirm, but those available give an indication of huge underutilization of the technology. Kenya is thought to have 14,000 digesters, Uganda 11,000, Ethiopia 10,000, with many countries believed to have far fewer than that. So why has this solution with incredible potential not taken off in Africa? Well, that felt like a very big why when you consider it has potential to drastically improve the health of nearly 1 billion people, while also making a huge reduction in greenhouse gas emissions. So we decided to make this question the main focus of our research. And we also felt it was important to focus on one country, but where? Seeing as Souleymane, my project partner, originates from rural Senegal, and the country has all the issues we've talked about so far, it felt like the logical choice for us. According to the World Bank, 51% of the Senegalese population live in rural areas. And despite urbanization, the actual number living in those areas continues to rise as population growth continues. A government study identified up to 400,000 households could benefit from a biogas digester. And this prompted the Senegalese government to introduce its national domestic biogas program in 2009. Through domestic and Swiss funding programs, the PNB aims to implement over 50,000 digester systems between 2021 and 2030. Now, paying for the initial upfront cost of domestic systems is often cited as a major stumbling block, holding the technology back in Africa. And the funding model of the PNB aims to solve this by guaranteeing loans in order to incentivize lending to biogas enterprises who will then market and install the digester systems.
Sorry, Steve, we have 3 minutes left.
Thank you. These enterprises will provide and install the systems crucially at no upfront cost to customers, and the customers then pay for their system over time with the digestate produced. The benefits of the program are incredible, I think. The renewable, clean, reliable fuel for cooking and heating in the home, deforestation, a huge reduction in deforestation, creation of local skilled jobs in a new green industry, production of 3 million tonnes of biofertilizer, and last but no means least, large reduction in greenhouse gases. So with the government's biogas program in place, how is it going? Well, we started by reaching out to relevant parties in Senegal, but got literally nothing back. So we hunted around online and found a fair amount of theorizing that all seems to agree that while there is huge potential for domestic anaerobic digestion in Senegal and across rural Africa, potential is sadly what it remains at the moment. But why? Well, that's where existing specific research and data gets very thin on the ground. So we decided to try and find out for ourselves on the ground in Senegal. Hopefully, with the help of Delft University and ETH Zurich, we intend to continue our research across after the course ends using 3 distinct methods. Phase 1, traditional market research. This will involve local researchers visiting farmers and rural communities in Senegal to ask locals in person questions like, what fuels are they using for cooking and heating? Have they heard of anaerobic digestion, and do they know of any AD system in place nearby? And what might stop them getting a digester, assuming they don't already have one? And are there specialist companies or engineers in their area installing or maintaining systems? Phase 2, we'll organise a prototype AD system to be built and set up in a Senegalese farm, providing biogas to the farm and a community cooking space. And a small documentary film crew will capture the whole process, including the challenges along the way, to show what happens when a Senegalese farmer attempts to do so. And phase 3, produce a research white paper on our findings on why anaerobic digestion uptake isn't higher across Senegal, and critically, how that might be improved.